A company currently connects its on-premises data center to a single VPC using AWS Site-to-Site VPNs over dual 1 gigabit per second direct connect links with public virtual interfaces. The company now needs to scale to 15 additional VPCs in the same region. The goal is to implement a solution that maintains encryption, avoids the use of public IP addresses, and keeps bandwidth utilization efficient. Which three actions provide the most effective architecture with minimal operational complexity?
A professional IT instructor explaining a certification exam question to students. The instructor reads the question and explains the correct answer. Clear, professional, educational. Style, confident, clear, educational tone. Pace, natural conversational pace. Accent, neutral American English. Option A, provision a transit gateway and a direct connect gateway. Link them and connect the additional VPCs to the transit gateway. Option B, establish a dedicated direct connect private virtual interface for every individual new VPC and link them to the direct connect gateway. Option C, configure a private IP address space for the transit gateway. Option D, configure a public IP address space for the transit gateway. Option E, set up a transit virtual interface to the direct connect gateway and deploy a site-to-site VPN connection using private IP addresses.
I believe the correct answers are A, C, and E. To maintain encryption while scaling to 15 additional VPCs without using public IP addresses, the company should utilize an AWS Transit Gateway combined with a Direct Connect Transit Virtual Interface. Option A creates the necessary hub-and-spoke architecture by connecting the Transit Gateway to a Direct Connect Gateway. Option E is vital because it creates the Transit VIF and an IPsec VPN connection, allowing for the use of private IP addresses for VPN endpoints, which satisfies the security requirements. Option C is also correct because when using a transit gateway for VPN termination, assigning a private IP CIDR block is mandatory to avoid public IP usage as specified. Regarding the other options, Option B is incorrect because creating an individual private VIF for every single VPC creates excessive management and operational overhead. Finally, Option D is wrong because the requirement explicitly forbids the use of public IP addresses. When designing these architectures, always look for ways to minimize manual configuration while prioritizing security.